Hello, my name is Claudio Pravettoni, and I'm an application engineer in Automotive Business Unit in Maxim Integrated. Today, I want to talk to you about the new product, MAX 25221. Let's start with the introduction. MAX 25221 is an automotive 4-channel TFT LCD power supply with VCOM buffer. MAX 25221 includes synchronous bus converter and inverter, providing plus and minus 10.5 voltage and current up to 200 mA. Integrated charge pump drivers, VG on and VG off. VG on diodes are integrated. VCOM buffer range of minus 2.49 volt to 1 voltage. VCOM step size of 6.83 millivolt, and also NTC temperature sensor allows for very precise calibration of VCOM over temperature. MTP also allows the output voltages and the sequencing to be pre-programmed, allowing fast turn-on time. So this is a typical application circuit with the frequency switch set to 2.1 MHz. And this is a very small size solution with a very low BOM cost. Design parameter. XPC allow for variable configuration of many parameters. Here we will evaluate the critical design parameters. The switch frequency of the boost converter, inverter, and charge pump is set by writing a single bit in the config register. The possible values are 2.1 MHz or 420 kHz. We set this value to 2.1 MHz. The output voltage on AVDD is set by writing a 6-bit value to the AVDD set register. We set the value to 6.8 voltage. The negative output voltage in NAVDD inverter is automatically regulated to the AVDD setting. The positive charge pump on VG on is set by writing a 6-bit value to the VG on register. We set the value to 10 volt. And the negative charge pump, VG off, is set by writing a 6-bit value to the VG off register setting. We set to minus 12 voltage. Select boost inverter inductor. The value of the boost inductor is determined as the following formula. We use a Lear value of 0.7 and efficiency of 90%. To calculate the inductor value is 2.5 microhenry. The nearest standard value used is 2.2 microhenry. The inductor saturation rating must exceed the maximum current limit to 2.25 amp. The value of the inverter inductor is determined as the following formula, using a Lear value of 0.9 and efficient about 90% to calculate the inductor value. The value is 5.9 microhenry, but the nearest standard value uses value of 4.7 microhenry. Also, the inductor saturation rate must exceed the maximum current limitation of 2.25 amp. Sufficient input capacitor must be used to avoid input voltage drop when transits are encountered on the AVDD or NAVDD outputs, and when the AVDD switch is closed. An input capacitor of 10 microfarad is a good starting value. On the boost output, use a ceramic capacitor of at least 10 microfarad to ensure stability. Output ripple can be faster reduced by increasing the output capacitor, will ensure a low ESR. A 10 microfarad ceramic capacitor is also needed on the NAVDD output to ensure stability. Increase these output capacitors, reduce output ripple factor. The VCOM output voltage can be set to a value between minus 2.49 voltage and plus 1 voltage by writing 9 bits. The most significant bits of the VCOM voltage setting are in the VCOM 25 register. The latest significant bit is a delay VCOM LSB register. To calculate the value to write to the VCOM 25 register using the following equation. This is a typical example of different value. This is the max 25221. This is the most important part. Input voltage filter and bulk capacitors. Boost input capacitors. Boost inductor. Boost output capacitor. Inverter input capacitor. Inverter inductor. Inverter output capacitors. VG-on flying capacitor and diode external, and also VG-on flying capacitor. This is the connector to Mini-Q USB. Software guide. The wiki also includes a Windows-compatible software that provides a simple guide. This is the most important functionality. I2C startup, default status, the burn command, the general configuration of the device, the rail setting, and the WCOM register setting. This is the lab setup. We have one EVKit board connected to a Mini-Q USB, one external power supply set into 3.3 voltage, number 5 digital multimeter for each output voltages, one external DC load, one oscilloscope, with also current probe. To complete also the software guide, we can start with the power up. Power on by I2C. I send a start from software guide. In the scope is present the I2C interface and the boost power up. The enable pin is high. Now I send a power down by I2C command. How can you see? You have the command, I2C command, and the power down of the boost converter. In standalone mode, the power up and power down are management from enable pin command. I put the enable pin high and the boost power up. Forcing the enable pin to low, the boost power down with internal discharge resistors. The power on and power off sequences are controlled by the sequence set bit. Now we can verify the power on and power off with different sequence order. In this case, the sequence number 3. The power on and power off sequences are controlled by the sequence set bits in the WCOM register. Now we can verify the power on with the default sequence number 3. We can set now a different sequencer, for example, number 1, and repeat the power up. It's possible to set a different delay time between each output voltage during the power up and power down. For example, now we set a 0 millisecond delay time and repeat the startup. We use an electrical DC load to check the transient load in the worst case condition. All the output voltages can be set by dedicated register. Now we change in the rail box on the GUI the output value, and we can read the cord value in the digital voltmeter. For example, EVDD. We increase the value until the maximum value. Thank you very much for your attention. For more information on the MAX 25221, please visit our website at maximeintegrated.com. Thanks.